Hello, Flat Earth researchers, debaters and debunkers. With this flexible ruler representing the surface of the Earth, we are going to disprove the ridiculous notion that the heliocentric model and the spinning globe best fit reality. You'll often hear people argue that the heliocentric model is the best at making predictions and it fits with the observations and measurements that we can make on the Earth. But we're going to do two things in this very simple demonstration that completely disprove that and show that it is perspective of our subjective observations that are converted into an illusionary objective reality to have us believe that we live on a globe, and we are going to debunk or disprove that the Erathostenes experiment somehow proves the circumference of us being on a globe Earth, and in fact it doesn't fit with reality at all. So just use your imagination to have this ruler representing the surface of the Earth, and the distance between these matchsticks can be whatever you like. It can be a mile, 10 miles, 100 miles, 1,000 miles. It's really up to you. And the matchsticks can represent lampposts, or the match heads can be the sun or moon or stars in the sky traveling off into the distance or above the surface of the Earth. And we'll see how perspective is converted into an imaginary curve, and that's simply by keeping in mind that this kind of view, this side-on orthographic view, is what you might call an objective view. We do not really have this kind of view of the Earth unless we are looking at something very distant, like a mountain range, or it could be windmills, or it could be the pylons across Lake Pontchartrain, if you like, often used as some kind of proof that we live on a spherical planet. But of course we are never really given this kind of view. It's almost impossible to fit this kind of view into a camera, so you have to get really far away in order to see it. But the view that we usually have is more like this, and we can see here how perspective comes into play. Now I've got the ruler level as I can make it, and of course you can see that what we get is this result of perspective, where you have the surface closest to us in the lower corner of the view, and this surface over here, or this end of the surface over here, rising up to the camera's eye level. And we also get this kind of declination of the tops of the matchsticks, simply due to perspective and angular size. Yeah, so I'll try and keep it horizontal. Yeah, and it's when we get this angle like this that we see what appears to be things sinking off into the distance. But that is then given to us in this side-on view, and the declination or the inclination of the surface that we see in this view is then converted into a curve on the surface. It's as simple as that. Yeah, this view, where we are looking horizontally across the surface and we see this inclination and declination, is then converted into a curved surface to give us that same inclination and declination. But the reality is that the surface actually remains flat. So we have perspective being converted into this imaginary curve. You see, it's really very simple. And we've got to keep in mind that any observation that we make as far as angles and distances don't change. This ruler is however long it is, doesn't change if we bend it or keep it flat. The distance between the matchsticks doesn't change, but it's all a matter of interpretation when we convert what we see in our subjective reality into this imaginary objective reality, and then we have to curve the surface to make that inclination or declination that we see from perspective and convert it into an imaginary curve. It's very simple. Again, the measurements or the angles do not change. You see, in this kind of view, we have angles. In this kind of view, we have no angles. So the angles are put in by giving the surface a curve that simply doesn't exist. Of course, in illustrations of the globe, we might be told to imagine that we are an observer here, for example, and of course what will happen is we then believe that we are looking into some kind of bulge of curvature, when the reality is that all we're doing is looking across a flat surface with a horizontal line of sight, and that surface appears to rise to eye level. Yeah? It's a simple conversion. Perspective becomes an imaginary curve. So what we have here now is a miniature version of the Erathostenes experiment. So again, we've got the curved surface of the Earth, and I've got this paper under it just so we can see the shadows more clearly in line with the curve. And when we shine a light on it, this is the kind of effect we get. We get shadows that do change in length and angle on this curved surface. But of course, the heliocentric model has us with a very, very distant sun. So if I make that sun more distant and bring the shadows out, you can see that what actually happens is that the shadows do become more parallel, and they become about the same length, which is not what we see in reality. What we see in reality is a close sun creating shadows of differing lengths. Yeah, you can see that as I take the light source away, as is with the heliocentric model, then the shadows become the same length all across the Earth. That shouldn't happen. And if this light source was much, much bigger, we simply wouldn't get clearly defined shadows across the surface, because the light would be shining down all over the surface. So to actually have shadows with a distant and massive sun on a curved Earth simply isn't possible. Yeah? So that in itself debunks the Eratosthenes experiment and the idea that the results somehow prove that we live on a curved Earth, because otherwise we'd have either no shadows with a massive light source, or we'd have shadows that are always an equal length the further away the sun is. So let's just put this down on the... I'll take this away now, we won't need it. Let's just make a flat Earth Eratosthenes experiment, and we can see here that we get exactly what we need to get, and something that fits with our observations, with a local sun. Above this point here we have no shadow, and we have those shadows getting longer and longer the further away they get from the light source. If I bring the light source over here, we can see that these shadows, and this one's a short shadow, these shadows get longer and longer as they get more distant. And we can actually keep the light at the same distance above the surface, and as we take it further away, then those shadows just get longer and longer. Yeah, so this again fits with our reality. If you ever watch sunsets, watch the shadows at sunset, you'll see that they just get longer and longer until they fade into obscurity because the light isn't reaching them any longer. So again, a local sun on a flat surface with shadows of varying lengths and angles completely fits with the flat Earth, okay? And it doesn't work on a curved surface with a distant and massive sun. Now, what I can try to do here is, just as a practical demonstration, just lift this up slightly, is if we use this as our, if we use the matchsticks to represent the angles at which we might observe the sun. Okay, these angles are going to get sharper and sharper as they get off into the distance. Okay, so basically what we're doing here is we are imagining we're looking at this light. So the angle on the surface of the Earth towards the light is like this. Again, this reflects what we can observe in reality, but of course what we're given with the illustrations of the globe is parallel lines of light. So again, remember that these matchsticks now represent represent the rays of light. So what's done, of course, is to have those parallel rays of light, we are then given a curved surface, and those angles then become straight lines. No, this isn't. Of course, people will laugh at this and say, oh, there's no precise measurements. It's not supposed to be. You can see for yourself that the angles that we would get on a flat surface are then turned into parallel lines when we are given a curved surface. So it really is just a matter of converting our subjective reality into an objective reality. Again, an objective reality that we don't see. We don't see parallel rays of light coming in. We see rays of light coming in like this, just as we saw with the shadows. So I hope that helps illustrate the difference between a flat and a curved surface, and show you that really the Erathostenes experiment and other such measurements or calculations for a model don't change anything. Nothing changes about the observations that we make. It is all down to how our subjective reality is converted into an imaginary objective reality. Thank you very much. Hello, Flat Earth researchers, debaters and debunkers. One of the most often cited so-called proofs that we live on a spherical Earth is to see ships apparently disappearing from the bottom up when they go off into the distance. When they reach the horizon, we are told that they are then going down a curve. And we are told that our height above the surface makes a difference to how far we can see along or down that curve. So with this very simple setup behind me, with some Tabasco sauce this time, HP Sauce is no longer a sponsor of this channel. We're going for something slightly hotter. It is very hot today, actually, very humid in this rainy season here in Phuket. Anyway, what we're going to do is just make an observation with this little setup here that anyone can then go and use to compare in a real life situation by looking across the surface of water and see what we actually see, and then confirm for themselves whether we are seeing ships disappear down a curve or whether it's due to other things, other factors such as perspective and the conditions, and of course the way light is reflected into our eyes, and also the nature of the rugged surface that we always see when we look across the water. Of course, these are very smooth surfaces that we are using, but we have to keep in mind that no surface in nature is ever completely smooth. So, of course, on tabletops and things like that, we're not going to see the bottom of something disappearing because we don't have those natural elements affecting the observation. So let's have a quick look at the setup. It's very, very simple. I've just got a flat piece of wood here that I've made pretty much level. Measurements and things don't make a difference. This is just a demonstration. And here we've got a curved piece of skirting board. And of course I've had to stick this on here because gravity won't hold this down on a slope. That's just an observation and a thought experiment that anyone can do. We know that, for example, if there was water on here, it would naturally flow down a curve. So, I mean, you can actually think for yourself that if we're told there's a curve at the horizon, but water doesn't flow down that curve, then that is simply a wrong assumption that goes against natural physics. You have to make up some mathematical model to imagine that there's some way that something can stick to a curve and water doesn't flow down it. But anyway, this is about making that observation. So let's just imagine that we are close to the surface and these source bottles are ships going off into the distance. If I just zoom in, of course, what we can see here is on the left, on this flat surface, and remember the bottle isn't quite at the end of the surface, it's about 2/3 of the way along, but it appears to be sitting on the horizon. And of course, if this surface was rugged and it had waves and there was sunlight acting on it and there were atmospheric conditions in between us, then this would make a difference to the visibility. And on the right here we have that curved surface, and of course what we do see is a bottle that has got a lot lower, and more than half of it has been cut off. It's debatable whether we can tell from this position whether that bottle is on the right is angling away from us. Of course, if we go back to this position, we can see that there is quite a significant angle to that bottle. Okay, so but this is the main thing I wanted to point out in this video, is that on the left, on this flat surface, at this low elevation above the surface, we see the bottle sitting on the horizon. But of course, what we're told about the observations we make for or the interpretation of this kind of setup or scenario on a globe is that the higher we go, the more we have to look down to see something going beyond a curve. So, but what we can see here is that as we rise up, the horizon or the surface beyond the red bottle on the flat surface now extends beyond the bottle, and the curved surface doesn't. It's gone down. We don't see beyond, we don't see any of the surface beyond the green bottle on the curved surface. So all you have to do is take this observation and go and make an observation across a real surface of water. It could be a lake, it could be the sea, and then make an observation from a low elevation like this, where the bottle on the left appears to be sitting on the horizon, and then go to a higher elevation. You could use a drone to do this if you wanted. Keeping the camera level, we see that on the left, the flat surface, it appears to extend now beyond the bottle. Yeah, down low, the bottle appears to be sitting on the horizon, but we know that the surface extends beyond it. We gain height above the surface and keep the camera level, and we can see that surface, the flat surface, extend beyond the red bottle. But with the green bottle on the curved surface, we cannot see that curved surface. Even if we angle down, we still cannot see that curved surface. It just ends there and cuts off. Okay, so obviously in the real world, just rising up a couple of inches like this could be the equivalent to several meters up into the air. And the higher we go, the longer we see the surface. And of course, this flat surface is very short. If it was long, it would just extend into the distance. And if it was infinitely long, then it would still rise to eye level. So yes, we do have these arguments about horizon drop. But if you think about what we mentioned earlier on with all the other factors taken into consideration, the limit to what we can see due to conditions and other factors or variables, then you can draw your own conclusions. But basically, if you go and look in the real world, what you will see when you look across the surface of the water is that surface extending beyond the object that was only on the horizon when we're at a low elevation like this. Okay, really simple. All right, so the next time you're near a beach or a lake, or you have the chance to make an observation near the surface and make another observation from higher up, this is all you have to do. And if you gain height and see that, just like we see on the left hand side with the red sauce bottle and the surface extending beyond that bottle when you gain height, you know it's a flat surface while keeping the camera level. If you don't see the surface extending beyond the bottle or the proverbial ship, then that would mean it is curved. All right? Really simple stuff.
That's it.
There you go. I mean, that ship appears to be on the horizon, but that could go further and further and further away, and it would remain on the horizon. And it'd probably get to a point where it would just get very fuzzy and we wouldn't be able to see it. Yeah? Because it's flat. Yeah? Look at that. And just another something to consider is that, of course, we could find a way to get some kind of drone or aircraft or whatever and fly straight and make this comparison with a side-on view, and then we would see that there is this significant difference in something that's gone down a curve. We can see that curve, we can see that the bottle is now angled, okay, and you will never be able to make this observation in real life. Okay, this is simply a scaled down demonstration of what we can look for, and I encourage people not to just take my word for it, but to go out and make their own observations. And you'll see for yourself that the idea that ships disappear down a curve when we see them going off into the distance is as ridiculous as it sounds. What we see in reality is a horizon that then, or a surface that then extends beyond the ship that was on the horizon when we were at a low level. All right, hope that helps. Thank you very much.